Good morning, afternoon, evening. How y'all doing today? Welcome back to Mr. Morrow's Algebra 2 class. Today we're going to double up our lessons and we're going to talk about 6.2 and 6.3, which is factoring trinomials, both in the form of x squared plus bx plus c, and I'm going to teach it to you in the form of ax plus bx plus c. So the reason I'm going to teach you both is because I've created two very similar ways of factoring, okay? Two very similar ways of factoring. So let's first talk about when our leading coefficient is a 1. Please remember that when I'm talking about a leading coefficient, the leading coefficient is the coefficient of the highest exponent variable. So when I have x squared plus bx plus c, my leading coefficient is an invisible 1, okay? So whenever I have x squared plus or minus blah, 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 I'm going to think about this factoring technique, okay? Please note that b is greater than 0 and c is greater than 0. Why? If b was 0, then I would just have x squared plus c. If c was 0, then I would just have x squared. And it's kind of hard to factor something that's just one term, okay? So let's get to it. All right, guys. I can only teach this by actually doing an example. I think that's the best way that I can do this. Okay, so let's get to it. First of all, I have x squared plus 11x plus 8. This lets me know, okay, I have a 1 in front of the x squared. My leading coefficient is a 1. I can do this procedure. And step 1 is nice and easy, the setup. So your setup literally is going to be x and x. Now, why did I put x and x? This is a power of 2 here, right, guys? Guys, what's half of 2? 1. Well, guess what? What's x times x? What do you do with the exponents? Add them. So doesn't x times x, doesn't that give you that x squared? That's where that comes from. But let me just go above and beyond real quick. What if I had a 4 here? It would be x squared, x squared. What if I had a 10 as an exponent? It'd be x to the 5th, x to the 5th. Are you guys with me there? So you always half the leading coefficient when it's in this format, okay? And later on, we'll be going into more detailed factoring where we use a method called substitution. But for now, whenever you see your exponent, it's going to be even, half it. And you're going to split it up in your setup. You with me so far, guys? Okay. Let me add one more thing in there too, just to be thorough. Sometimes we're going to wrap it up with maybe a y squared at the back end. Same concept. But this time, what do you think, my man? Correct. This time you'll have a y and a y. How come, Mr. Morrow? Because y times y is y squared. If I had a y to the 8th here, what would I have had at the back end? Y to the 4th, y to the 4th. So set up really crystal clear, guys. Promise? Thank you. Okay, so that's my setup. So my setup, ooh, that was hard. X plus x, okay? X and x. Now, number 2, very important question. What number times what other number equals the c value, but when added together equals b? That's a very important question, and you got to learn how to ask yourself that. What times what equals 18 in this case, but when added together is 11? Now, here's where, remember how I've been telling you since day 1, guys, you got to know your times tables, like backwards and forwards. Remember that, guys? Right now, today, this is what I was hoping to prepare you for. So, guys, you got to know how to do this, and you got to know your times tables. So, let's go. What times what is 18? What add together is 11. That's it. 2 and 9. So, bam. 9 times 2 is 18. 9 plus 2 is 11. So, I am now literally going to plug it in to my setup. Literally. That's it. Plug in answers into setup. You're done. It does not matter because they're both plus. If you had a negative, the negative would have to go to the negative one and the positive would go to the positive one. But no, you don't have to have 9 first or 2 first. It doesn't matter. Thank you. Okay, guys, so that's it. Literally, literally, that's it. That's it. Now, the book teaches it a different way. Yes, I know. The book and most other people are going to teach it where they want you to list out all of the possibilities. So what the book wants you to do, or maybe another teacher would want you to do, they want you to do this. Okay, you have your x and your x, okay? And then what times what is 18, but when added together is 11? Well, they want you to put, okay, it could be 3 and 6. It could be 2 and 9. It could be 1 and 18, etc., etc. Wants you to list all of those out. Then it wants you to actually multiply them out and then see which one gives you the answer. That's ridiculous, in my opinion. If you need to do that because you're not good at multiplication, that's fine, but you're never going to finish tests on time. So I have warned you before. Unfortunately, it's coming true. If you don't know how to multiply, guys, it's going to be a very difficult section for you. Now, sign patterns, okay? If you memorize the below patterns, it helps you find your factored answers easier. You don't have to memorize this. You don't have to. This is just going to make your life easier, and you'll see what I mean. Okay, when the given trinomial is in the form of positive x squared, positive bx, positive c, your signs are always going to be positive, always. So it's going to be x plus and x plus, always. When everything is positive, it's nice and easy. Everything is x plus, x plus. Now, when the given trinomial is in the form of x squared plus bx minus c, you're going to have a plus and a minus. It's going to be x plus, x minus. Every time. There's no exception to this. When the given trinomial is in the form of x squared minus bx minus c, it's also going to be in the form of x plus, x minus. I promise. Always. Bless you. And last but not least, if it is in the form of x squared minus bx plus c, it's going to be x minus, x minus. Always. I promise. Every single time. I just wanted you to see it all. So again, all positive plus plus. Positive b negative c plus minus. Negative b negative c plus minus. Negative b positive c minus minus. You do not have to memorize that. The answers will come naturally with your multiplying, but it's really good to know the setup already because then you don't have to worry about the signs. Okay? That's literally it for 6-2. Now we're going to do some examples unless you have any questions for me. So thank you. You're wonderful. The question was, if you ever factored something out, and let's say you got x plus 2 and it factored out to x plus 2, could you write it as x plus 2 squared? Yes. In fact, that's why we learned how to multiply that. You just made me very happy. Thank you, my man. Great connection. Guys, remember what we said. All of this factoring stuff is the reverse of multiplying. We already multiplied. We went forward. Now we're learning how to factor. We're going backwards. Okay? So, let's go do it. Okay, r squared plus 11 plus 24. I do not ever start this without doing my setup. I've been doing this for 20 some odd years. I do it every time the same way. Please do what I say. What times what is 24 but when added together is 11? 8 and 3, you're done. Bye-bye. Have a good day. Sir, the order does not matter, sir. Thank you for asking, my brother. How about the next one? Okay, I've got a minus plus. So what do you know about the setup here? Thank you. It's going to be y minus, and I'll explain why now. What times what is 8, but when added together is negative 6? Negative 4, negative 2. What's negative 4 times negative 2? Positive 8. What's negative 4 minus 2? Negative 6. Does that make sense, guys? Okay, let's keep cranking it out. Oh, I got x squared minus 11xy plus 24y squared. What's my setup look like here? X and a y, x and a y. What are the signs? Minus, minus. Beautiful. What times what is 24, but when I have to go is negative 11? So you got a negative 3, negative 8. Done. Make sense? Okay, next, x squared minus x plus 2. What's my setup look like? What times what is negative 2, but when added together is negative 1? No. Let me rephrase that. What times what is positive 2, but when added together is negative 1? Negative 1 times negative 1 is now positive 2. Negative 1 times positive 2 is now positive 2. Negative 1 and negative 2 is positive 2, but negative 1 minus 2 is not negative 1. Thank you. It's prime. When you can't factor it, my brothers, it's prime. Very good. Remember, it may look obvious, but always test it, guys. Always test it. The negative 1 and the negative 2 is the most popular answer for this. Because, yes, negative 1 times negative 2 does equal positive 2. But negative 1 minus 2 is negative 3, and you need a negative 1. So in this case, that's prime. I will put that on quizzes. I will put that on tests. The SAT will give you maybe one like that that's prime. So know how to deal with that. Thank you, guys. Next. Okay, I got x squared plus 2x. What's my setup look like? X plus, x minus. Very good. What times what is negative 15, but what I have to get is positive 2. Positive 5, negative 3. Here the order does matter. The 5 has to be the positive one. The 3 has to be the negative one. Correct. If you reverse and you went x minus 5 times x plus 3, then you'd have a negative 15 here, but you'd have a negative 2 there. Thank you. Next, 6x squared plus 9x minus 36. What does my setup look like here? X plus, x minus. What times what is negative 36, but when added together is 9? 12 and negative 3. Thank you. Great job. Okay, what's my setup look here? Hold on. I don't know why the screen does that sometimes. Okay. XY, and it's plus plus. Very good. What times what is 30? When added together is 31. This is a good one. 30 and 1. Very good. 30 and 1. Done. Do you see how this is actually pretty awesome? Okay? You don't have to make test values and tables and all this stuff that all these other books and teachers want you to do. If you know the procedure here and you know how to multiply and add, you can do it in no time. How about this bad boy? X squared minus 3x minus 40. What's my setup look like? X plus, x minus. Okay, what times what is negative 40? But wow, but when added together is negative 3. Perfect. Positive 5, negative 8. Because 5 times negative 8 is negative 40. 5 minus 8 is negative 3. Okay, now, I got 5y squared minus 20y minus 160. What do I always do first, though? What do I always look for? I look for a GCF. Thank you. Do I have a GCF here? So pull it out. So I got 5y squared minus 4y minus 32, I believe. Right? Yeah. Now, what's my setup look like? Got to keep that 5. Y plus minus. What times what is negative 32, but when added together is negative 4? Sir. Plus 4, negative 8. Who do we appreciate? Great. Good job. Notice, the GCF skill will be with us forever. Now you may say, Moro, you didn't ask for the GCF for any of these up here because there was no GCF. You're right, there was no GCF. But here, there is a GCF. For example 10, my brothers, do I have a Thank you, you took the words right out of my mouth. Take out the negative 3, so I got x squared plus 2x plus 8. My setup is x plus. What times what is 8, but when added together is 2? What times what is 8, but when added together is positive 2? Nothing, thank you. No, it's not prime, because I took out a GCF. So it has one common factor of the negative 3, so that's technically not prime. Prime is when you can't take out a GCF, you can't factor a trinomial, you just can't do anything, it stays the same. That's a great question. Thank you, my brother. Come again, my man? You literally, this is the answer, what I just circled. That's it. I took out a negative 3, that's all I could take out in this particular case. Does it make sense, my brothers? Okay. May I continue? Okay, ready? I'm going to crank it up now a little notch. All right, guys, this is the one that makes a lot of people scared. All right, now, I'll tell you a little story real quick. When I first started teaching, I was petrified of teaching this, okay? Because the way you technically have to do this, you have to list all the factors of A, you have to list all the factors of C. Then you got to put them in binomials. Then you have to test each one that you set up, and then you find the two binomials that work. That is horrifying. It is time consuming, it is long, and that's how I used to teach it. So I was at a library one day tutoring a student, and this awesome old man came up to us and he's like, hey, I'm sorry to bother you, but I was a math professor in Cuba, and I've got a much easier way for you. And I'm looking at this guy and I said, no, come on. And it was true, man. So he showed me this way. This is not Mr. Morrow who invented this. This is someone a lot smarter than me, but I learned from him. I practiced from him, and now I teach it to all my students, and I think you're going to love it, okay? I think. So step 1, setup. Setup is very similar to the last setup, except you're going to put AX, AX. So that means you're literally going to repeat the A on both of your parentheses. Now, right off the bat, you may say, Moro, come on. 5x times 5x is 25x, Mr. Moro. You have a typo here. I don't. I promise you. This is not math. This is a trick that I'm going to teach you. Okay? So my first setup, whenever I have an A, it's AX, AX. And again, if this was AX to the 5x to the 8th, this would be 5x to the 4th, 5x to the 4th, right? Everything stays the same. The only thing that differs is now you're going to put A on both. You feel me? Okay, now, step 2. Multiply the A and the C to find a new C. So I'm literally going to multiply 5 times 2, and that's going to be 10. That's my new C. Now that I have a new C, guys, it's literally the same thing that we just finished learning. What times what is the new C, but when added together equals B. So guys, what times what is my new C of 10, but when added together is 11? 10 and 1, very good. So step 4, plug it in. So I got 5x plus 10 times 5x plus 1. I'm going to stop right there because I know I'm going fast. And I want to make sure that everyone has this up to step 4. I'm going to pause, in fact, for a second. I want everyone to be on point up to step 4. I'm going to pause right now. Okay, gentlemen, thank you for that, and thank you for the questions. Now, this is the most important part, and this is where the trick comes in. This is called imaginary factoring. Now, you may say, what are you doing to me, Mr. Morrow? Well, let me explain. Guys, do you have a common factor here? We've already learned that if I pull out a GCF, this technically should be then 5 times x plus 2, right? But this is a trick. The cubic method is a trick. So I'm going to imaginary factor. So I'm going to go bye-bye. I just take away the 5. It just up and disappears. How, Moto? It's a trick. This is not math. I'm not doing technically math here. This is a trick. So then I have, I can't take anything out of 5x plus 1. So that's it, guys. I'm done. It's over. That's it. That's it. That is it. Okay? Or if you want, you could do this. You go, okay. You go to the beginning, you go, okay. This could be a 5x and a 1 and then a 5x and a 10. I mean, a 1x and a 10. Or it could be a 5x and a 10 and then an x and a 1. Or it could be a 5x and a 2 and then a x and a 5. Or it could be a 5x and a 5 and then an x and a 2. If you want to write all of those down, you want to test all of those out, God bless you. Godspeed, man. Do it. I do not suggest that. It's going to take an extremely long time. Now, let's do another one so you can really get to this. Okay, let's factor polynomial. Okay. Now we get a little bit tougher because 8 has a lot more factors. So this would have been a mission if you do it the quote-unquote technical way that you're supposed to do it. But we're going to use the cubic method. So my procedure, my setup, okay? My setup is, whoa, why is this? There we go. Okay, first I'm going to find my new C. Now, what times what is negative C, but when added together is B. Got negative 10. All right. Okay, this is another procedure. This is a new way, another way to do it. Okay. Then, step 3, you can group the two numbers. I don't like this method. You can group the two numbers with the first and last term, A and C. So, you found your new C. You said what times what what times what is the C, but when added together is the B. You got negative 12 and 2x. So now you can take this negative 12 and attach it to that original 3x, just like I did here, plus take that positive 2x, attach it to the negative 8, like I did here, and then go ahead and factor by grouping. So I could take out a 3x, I could take out a 2, and then I can factor out an x minus 4, and I have a leftover of 3x plus 2. I'm going to put this all up so you can see it all. Okay? So this is another method to do this. Yes, sir. To me, the cubic method is the king. To me. No, it's not just a reverse foiling. There's 4 steps to 5 steps to the cubic method. So no. This is another method. This is factoring by grouping. I don't like this one as much. But if you like this, God bless you. I'm not gonna shame you into doing it my way. This is fine. Again, how does this one work? You take the A and the C, and you find a new C. Okay? In this case, negative 24. Now you ask, what times what is negative 24, but when added together is negative 10x. So that's negative 12x and positive 2. You take the negative 12x and you attach it to the first term. You take the 2x and you attach it to the last term. And now you factor by grouping, which we know how to do. I can take a 3x out of here, left with x minus 4. What do I need to take out of here to be left with an x minus 4? I can take out a 2. I'm left with x minus 4. Now I have an x minus 4 and x minus 4. And I have my 3x plus 2. And actually, that's a multiply. So that's another method. Yes, sir. Yes, they have to accept that method. There's nothing wrong mathematically with that. I, it's an imaginary factor. I mean, if you're in a class where they tell you you have to do it one way or the other, you're gonna have to listen to the teacher. But let's be honest. I'm trying to think of math in the real world, or like if you're on an SAT, or if you're an engineer and you want to figure out the maximum point of a quadratic equation for a bridge that you're building. You mean to tell me you can't use this? No one's going to come behind you and say, hey, how did you divide that 5? This is a legitimate way, the cubic method, legit. More mathematical is this way, yes, for sure. If you have a picky teacher, you got to do what they say because that's their boss. That's your boss. That's your boss. Okay? Yes, sir. Yes, sir. Step 4. Whoa. Yes, sir. Yeah, if you can't, sometimes you can do an imaginary factor to one term. Sometimes you can do it to both terms. You're always going to do it to at least one, though. Maybe sometimes to both. Why don't we do some examples, guys? Okay? Now, for example, 3x squared plus 5x plus 2. Check it out. Bless you. I got 3x, 3x. My new c is 6. What times what is 6 when we add together is 5, guys? Positive 3, positive 2. Imaginary factor, x plus 1 times 3x plus 2. Come on, be honest. That's clutch, dude. It's fast, easy, quick, and very efficient. Very efficient. Does it make sense? Okay. Number 3. I got 8x, and I got 8x. 8 times 15 is 80 and 40, 120. So now you got under your times tables. What times what is 120? But when added together is 22. 12 and 10. Thank you. So positive 12, positive 10. I can imaginary factor a 4 from here and a 2 from here. So I'm left with 2x plus 3 times 4x plus 5. Guys, I know I'm a bit of a math dork, but isn't that awesome? It's quick. It's easy. Efficient. To the point. Does that make sense? Yes, sir. In this particular case, because I had a common factor here and a common factor here. But for example, in this one, I only had a common factor here, but not here, so that stays the same. Correct. You imaginary factor that bad boy out. For sure. Thank you so much, sir. Next. Okay, I got 6x, 6x. 6 times 5, that's my new c is 30. What times what is 30, but when added together is 13? Bam. Positive 3, positive 10. In this case, I could take out a 3 from here and a 2. So I've got 2x plus 1 times 3x plus 5. Just making sense, guys. 3x squared plus 16x plus 5. Okay, I got 3x, 3x. New c is 15. What times what is 15, but when added together is 16? 1 and 15. I can imaginary factor a 3. So I got 3x plus 1 times 3x, no, modo, x plus 5. Does it make sense, guys? Okay. Now, yes, sir. If it was 3x to the 6th, then that'd be 3x cubed and 3x cubed, and that'd be 3x cubed and an x cubed here. If, yeah, you always split up those exponents evenly, always. Just like the normal setup, sir. Now, You don't like the grouping way. Some of you may have just fallen in love with the Cuban method. Some of you may still be like, I don't like it. I got a third way for you guys. This is called the box method, okay? The box method, I know this is crazy, but you make a box. It's crazy. Okay. Guys, what are some possible factors of 2x squared? 1x times 2x. Okay, good. Now, what are some possible factors of negative 7? Okay, negative 1 and 7. Now, you ready? I'm going to make magic happen. Guys, what's 7 times x? 7x. What's 2 times negative 1? Negative 2x. So 7x minus 2x equal negative 13? No. So that doesn't work. New combo. You had negative 1 and 7. Now let's reverse it. Let's put negative 7 and 1. Or actually, don't even put any signs. X times 1 is what? 1x. 2x times 7 is what? 14x. Can I manipulate the signs here so that 1x and 14x can equal negative 13? How? This would be the negative 7 here, and this would be positive. Well, this is x minus 7 times 2x plus 1. That is another way you could do this. This way also involves a lot of guessing and checking. Me personally, I would have done it like this. 2x, 2x. 2 times negative 7, my new c is negative 14. What times what is negative 14, but when I add it together it's negative 13. Negative 14, positive 1, imaginary factor. You guys have to make the decision. What do you like better? Because I'm not going to tell you what to do. I gave you 3 tools. Use the tool that you love. Does that make sense? Last but not least. Can I erase this? Last but not least. Which way do you want me to do it? Box method, grouping method, or Cuban method? All right. So I got 4x. 4x. 4 times negative 3 is negative 12. What times what is negative 12? But when I have to get is positive 4. No. Positive 6, negative 2. Very good. Take out a 2, take out a 2. So I got 2x plus 3 times 2x minus 1. And we're done. Does that make sense, guys? Now, there is one warning for you. Sometimes the Cuban method is beautiful. I love it. But sometimes you get to some pretty nasty, huge numbers that make it very difficult to do the actual math. So in that case, it's good to know the box method. For example, real quick, guys. Let's say, let's see, okay. Let's say I had, you know what, I can't find one right now and the bell's about to ring. When you're going through the homework, if you get a situation where you get a really nasty new C, you can always use the box method. And again, real quick, the box method, split this up into its potential factors. So x and 2x. Then split up all the possibilities for your constant C. Cross multiply and see if you get your middle term. If your first guess doesn't work, go back to the drawing board. But that's only going to happen very rarely when there's a giant number for the new C. I hope you guys learned a lot. Homework is valid. God bless you all. Thank you for a great lesson. Have a great weekend. Be good. Thank you.